You have solved in the past polynomial equations and inequalities. Now we're just going to take it one more step and we're going to solve rational equations and inequalities. Now, you guys did in Algebra 2, you learned some basic graphing. This graph, I don't know why I look at my finger. It's not like my finger's going to change anything. So let's try this again. This function, where'd it go? Did it move again? Yeah. Okay. I circled the wrong one. It goes with this graph right here. Now, I want you to see what you remember. Do you remember how you get a vertical asymptote? That's right, it's where the denominator's undefined, where the fraction's undefined. Now, how would you figure out where a fraction is undefined? Where the denominator's 0, good. Now, in this equation, how can I figure out where the denominator is 0? By doing what? Factor. So if we factor, let's just go ahead and factor the numerator and denominator. How does the numerator factor?
3 and 1. 3 and 1.
How does the denominator factor? Yes? So where is this fraction undefined? At x equal 1 and at x equal negative 3. That's right. But here's the question. There's a vertical asymptote at x equal 1, but there's a hole at x equal negative 3. Ah. If you recall, did you do holes in Algebra 2?
Yes.
When you have a common factor that you can factor out, what that produces is a hole. Any factor that you can't factor out of the denominator produces that vertical asymptote. How do you know where that hole is in terms of its y value? I know I have a hole when x equal negative 3, but what's the y value there? Plug it into what? I mean, if I plug it into here, I'm going to get 0 over 0. I'm going to plug it into here. I'm going to plug it into my simplified fraction. If I let x equal negative 3, what's that numerator? Over, if I let x equal negative 3, simplifies to what? 1/2. So the point negative 3, 1/2 is where my hole is, and that's where you can see that hole.
How do they get
The horizontal? I show you. You did it in Algebra 2. You may not have enjoyed it, but you did it. It has to do with the degrees of the numerator and denominator. Yeah, what? What's the degree of your numerator? 2. What's the degree of your denominator?
2.
If the degrees of the numerator and denominator are the same, then your horizontal asymptote is just those coefficients. So it'll be y equals 1 over 1, or y equals 1. That's where you get your horizontal asymptote. What happens if they're not the same? If the degree of the denominator had been 3, the degree of the numerator is smaller than the degree of the denominator. Now, we will at some point go into all the why, but we're not going to right now. If the degree of the numerator is smaller, then the horizontal asymptote is going to be y equals 0. It'll be the x-axis. If the top is bigger, there is no horizontal asymptote. Okay, use the graph to identify the values for which the following equations or inequalities are true. I don't know why there's a question, because that's not a question, that's a statement. But okay. All right. Where is that function equal to 0? At x equal negative 1. Right there. I'm sorry? Only crosses the x-axis one time. What about number 2? Remember, g of x is just another name for what? For the y values. So in number 2, the question is where the y value is positive. What does that mean on a graph? Above the x-axis. Where in this thing is the graph above the x-axis? Oops, I meant to have a this. That's all above the x-axis. So how do I write that in interval notation? Well, we've got an arrow. Yeah. So negative infinity. Always use the x values. Correct. You said to negative 3.
Is that a bracket? No.
Is negative 1 included? No. Where do I start the next piece? Right. And that's what the parentheses takes care of. So 1's not included. Correct. That's where the asymptote is. What about question 3, 4? What about question 4? 3, 4. Question 4. No, we're on 3, aren't we? Dummy. Graphically, what does 3 mean? Below the x-axis. Which happens where? Negative 1 to 1. What about the ends? Is any more of that graph below the x-axis? No, that's it. That's it. What about number 4? What does number 4 mean graphically? Good. On or above. Good. So where is this graph on or above the x-axis? Negative infinity to negative 3. Negative 3 to negative 1. But include negative 1. Good. Yep. And what about 5? What does that mean, less than or equal to, graphically? On or below. Good. On or below. What about the ends? Bracket on, bracket on the left side. The goal of this lesson is to learn a strategy to algebraically solve rational inequalities. How can I find these answers that we put in this table without looking at the graph? That's what we're going to try to figure out. The process is identical to solving polynomial inequalities with one exception, and that exception is in the polynomials we didn't have a denominator. So all we got to do is deal with the denominator. That's the only thing different. Given this function, which I believe is the function that we were working with right here, find g of negative 3. Find g of negative 3. And then find g of 1. What'd you get for the first one? G of negative 3. 1/2?
No, I didn't get that.
Oh, undefined. What numbers did you get? What over what?
0.
0 over 0? What'd you get on g of 1?
8 over 0.
both undefined. At which one of those x values did you have the hole? At -3.
Oh, yeah.
At, well, we'll talk about it in a minute. What did we have at x equal 1? The vertical asymptote. Ladies and gentlemen, anytime you do a substitution and you get a non-zero number divided by 0, you're going to have a vertical asymptote. If you get 0 divided by 0, you're going to have a hole. We've really done the next piece. Instead, using the graph, explain why your efforts to find those two numbers had the outcome they did. We knew the graph was undefined at those two numbers, but now we know the difference between a hole and a vertical asymptote. Now let's go down to this one I circled earlier. Identify the values of x that make the function equal to 0 and the values of the function x which and the values of x which makes the function undefined. What values of x made this thing equal 0? -1. And undefined? Good. All right, so far so good? Isn't that where you have a vertical asymptote? Now let's talk about these steps. To solve rational inequalities, the process to follow is identical to the process you learned with polynomial inequalities. Remember that problem that we practiced right before lunch? Except in the case of rational inequalities, we must not only divide the number line for the sign analysis, this is a long sentence, using values that make the function equal 0, but also using values that make the function undefined. Long story short, where's the numerator 0 and where's the denominator 0? Though we've got to find all the critical numbers. And in calculus you will learn that a critical number means equal 0 or undefined. Now, completely factor the rational function provided it's not already factored. We've already done that, yes? What was this? We had x plus 3 times x plus 1 over, thank you. Now let's look at step 2. Set each factor equal to 0, all of them. If I set this one equal to 0, I would get x equals those are my critical numbers. Do you have questions about where those came from? Draw a line, a number line, and we're going to divide it into segments using those zeros. Now you know the smallest one, I hope. How many regions have we divided this number line into? 4. 4. There are 4. We're on the author's number 3. Choose a number from each interval. Pick a number.
4, -4.
-4. Keep going. And determine the sign of each factor of the rational function based on the chosen value. This will help you to determine if the entire rational is positive or negative on the interval in question. Okay, all you're going to do here is you're going to take this -4 and you're going to put it back in here. That's what you're going to do. And you're going to decide if that answer is positive or negative. If x is negative 4, negative times negative over, if x is negative 4, negative times negative, right? Positive divided by positive. Negative 2. What about here? Positive times negative. Denominator, if x is negative 2. Positive times negative.
That's positive.
That's also a positive. What about x equals 0? Positive times positive over positive times negative. What's that? That's negative. Yeah, probably. What about at x equal 2? Positive times positive over positive times positive. I sure hope that's positive. Now let's look at step 5. Refer to the original inequality. In this particular example, that's the symbol, which means the solution will be the values that make the polynomial negative or 0. Yes? What intervals make this rational function negative? Between -1 and 1. Now we got to talk about the endpoints. We got to talk about our critical numbers. Now you got to look at all three of these critical numbers, -3, -1, and 1. Does -3 make this rational function less than or equal to 0?
Makes it 0.
-3 made it be 0 over 0, right? Which means whole. So does -3 make this expression less than or equal to 0? No, because it's undefined. And undefined is not less than 0, and undefined is not equal to 0. So -3, shoo. Remember, I would really encourage you to think this. What about x equal -1? If x is -1, what's the numerator? 0. And if x is -1, what's the denominator? What's 0 divided by -2? What's 0 divided by -2? 0. 0. Is 0 less than or equal to 0? Yeah, it's equal. So that works. -1 works. What about 1? If x is 1, what do I have? 2 over 0. That's undefined, meaning there's a what? No, not a whole on that one. If you get non-zero divided by 0, you have a vertical asymptote. Yeah. Now refer to the picture of the graph right here. How does my analysis confirm my graph? I was looking for less than or equal to 0. And what I got was -1 to 1. Is that right? Is that the region that is on or below the x-axis? Nailed it. Nailed it. This is what we're doing today. This is it. Now Sparks has got a couple of these with all the instructions. First of all, completely factor. Done. Done. Set each factor equal to 0, and we're going to find our critical numbers. Our critical numbers are where each of those factors is equal to 0. What's our critical number here? -3, 1, -2. -3, 1, -2. Before we go any farther, do any of those critical numbers make this rational function undefined? -2 does, because -2 does what? Makes the denominator 0. Now, so let's think, at x equal -2, we know our function's undefined. Is there going to be a hole there, or is there going to be a vertical asymptote there? Why a vertical asymptote? Because the numerator's not 0. Good, good. Are we going to have any holes here?
No.
No holes. Good. All right, let's draw our number line. -3, -2, and 1. We're going to pick a number in each of those intervals. I use -2.5. We can handle it. We'll survive. Remember, I don't need the number that comes out. I just need to know if it's positive or negative. It's still gross. -4. Negative times a negative. Listen, look right there at that thing. Always positive. Because squared. So that thing's always positive unless x is -2. Yeah, which makes the fraction undefined. So this gives us what? It gives us a positive. -2.5. Positive times negative over. So I got positive times negative over positive. That's negative. 0. Positive times negative over positive. What's that give us? Negative. Negative. 2. 2. Positive. 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 Now go back to the problem, and what you're going to look for is that right there. What intervals make this thing negative? Okay, let's talk about that. Is it going to be -3 to 1? If so, then that means -2 is included.
No.
Is -2 an answer?
No.
Right, it's an asymptote, so are we going to have to, can we make this with one interval, -3 to 1, or do we need to make it 2 intervals? Yeah, we're going to need to make this 2 intervals. So we're going to say -3 to -2, and then we're going to say -2 to 1. Let's talk about your... Correct, because if you have a vertical asymptote, then your function is undefined there, which means there's not a number when x is whatever that is. Now let's talk about parentheses or brackets. All we were looking for was less than 0. Does -3 make this less than 0? What does -3 do to this if I plug in -3? What if x is negative 3? Right there.
Zero.
That's 0. So this will be 0 over. Is the bottom going to be 0 when x is negative 3? No. So it'll be 0 divided by some number that's not 0. What is that?
It's just a thing. It's a regular old deal.
It's just 0. There's just 0. Isn't 0 divided by 1 equal to 0? It's just 0. So is that included? No, because that's just less than. It's not on the x-axis, it's just less than. So x equal negative 3 is not included because negative 3 makes this thing equal to 0. What other number makes this equal to 0? 1. So 1's not included either. Is negative 2 included? Is negative 2 an answer? Does negative 2 make this less than 0? No, what's negative 2 do to the darn thing? Makes the sucker undefined. So what are my ends? That's right, they're all parentheses. They're all parentheses. Now, you've got that answer. Let's look at the graph. Does your answer support what the graph shows? You were looking for less than 0. What does less than 0 mean graphically? Below the x-axis. Good. Are we below the x-axis right here and right here? Yes? No, that's not supposed to be a dot. But so between negative 3 and negative 2, and then between negative 2 and 1. All right, solve them. I'll tell you what. Let's just do the one on the left, and then we'll decide if we need to do the one on the right. Oh, by the way, you need your calculator. I should have told you that earlier.
You got it.
We're going to work this one in the upper left corner, and then we're going to work the one on the bottom.
You can't see the one.
Can't see the one on the bottom. So, look at the one on the left. We're going to solve that rational inequality. Now, notice that Sparks did not include the steps here, so let's see if you can remember the steps. Factor.
Mark
Okay.
Marker.
Factor. That's right. That denominator won't factor.
I did that now.
That's not right. That's not right. Yes, sir.
Factor the top one.
Now, remember, the goal is when is the numerator equal to 0 and when is the denominator equal to 0. Those are going to be our critical numbers. When is that numerator equal to 0? When x is 3. So 3 is one of our critical numbers. How do I figure out, whoops, probably don't want to do that with a highlighter. How do I figure out, I do too. How do I figure out when that's 0? I could do quadratic formula.
Oh.
Or I could do what else?
Quadratic formula. Why?
Complete the square.
Complete the square. I don't like.
Okay. Yeah, let's just review completing the square so that you can get it back in your head. Completing a square is really easy when your leading coefficient is 1 and that middle term is even. Completing the square is real easy. If you remember, you take your constant and move it to the other side and leave a little space. to complete the square, what do you do with that number? Half it and square it. So, but if you add 4 to one side of an equation, by Jove, I think you got it. If you have put the correct number in purple, which you have, then this will factor into something times itself. How do we work to get that x alone?
You gotta add.
Square root both sides, and then
And then it's the.
so x plus. These guys are idiots. It's a good thing I love you. It's a good thing I love you. Yeah, I know. Don't forget the plus or minus. You hear me? Don't forget the plus or minus. I'd rather say what Frankie said earlier when he was looking at his test. I'm a buffoon. I'm a buffoon. Now, how do you isolate the x? I subtract 2 from both sides. By the way, they asked me to talk in a British accent. I would not do that on my own. Now,
Table.
now, I want to know what these numbers are so that I can put them on the number line.
It sounds like elbow.
On your calculator, I want you to run -2 plus root 2. Give me an answer to 3 decimals. -2 plus root 2. 0.5 what?
Table. It should now.
Now run it by doing -2 minus square root 2. Negative what?
That's pi.
That is not pi. Ladies and gentlemen, those are your critical numbers. We can't talk in a British accent. I have to go and watch the movie again. So x is, oh, would help if I go over the right problem. X is 3, -3.414, and is that right? 586? Is that right?
Negative.
Are both of them negative?
Yeah.
Put those on a number line.
Four.
I don't think I will.
You win or you finish.
Oh, mercy. -3.414.
Oh, good lord. No, that line is perfectly straight.
Now we're going to take each of the numbers I've got in red. Thank you. Thank you. Now we're just going to have to plug them into the original because we couldn't factor the denominator. If x is -4, is the numerator positive or negative?
Negative.
Negative. Divided by.
A positive.
-4 squared. 16 plus.
Plus -16.
No, still. Which is actually a negative. Can we just
Okay, Frankie,
Go, Frankie.
okay, borrow points.
Okay. What are we doing?
Check x equals
Okay,
negative-
this.
No, check x equal -1.
Oh yeah, -1. That's a negative. Positive, negative. Wait, that's
So,
one.
-1 squared is 1.
Yeah.
4 times 1 is 4.
4 times 1 is -1.
No, 4 times -1 is -4.
Yeah.
So it's
Negative. Negative over negative is positive.
Oh my. That's a plus right there.
Chris, why don't you get lost?
Yeah. Why isn't Tristan doing this?
Uh,
I don't have the brain power.
0.
That's. You know what? You're absolutely right.
0 minus
All right. 0 minus -3 is -3. That's 9.
plus 2.
That's a 9, by the way. Yeah. Oh, 0. Oh, yeah. I was doing 3. I'm still losing my mind. Oh my god.
Frankie,
Watch
just
this
do
video,
that,
then write that down.
back,
It's like,
yeah.
oh, I was thinking of 3.
There we go.
Alright.
So it's 0 plus 2.
Yeah, you're right. Alright.
Negative over positive is negative.
Yeah.
Wait, try that again. Negative divided by a positive is what?
Negative.
See, I didn't even do that extra line.
Okay. So let's see.
How you?
Positive for positive. That's positive.
Are you positive?
No.
No. Okay, 4. Okay, that was 1 over 16 plus 16 plus 2. That's 6. That's numbers. So that's positive. I can't do this with my left hand. I'm not Miss Stennett.
It's just weird because then she teaches on that side.
Is that X over positive?
Like everyone's.
So go back to the right. Let's finish the problem.
This is. What do we do now? Hold on. Let me check my notes.
11.
Now what? Oh yeah. So this has to be. Yeah. Why would you like me to do this, Miss Stennett?
That's right.
All right. Okay, so we gotta find whether it's on or above the x-axis.
That's right. On or above.
So where it's positive. So this one and this one.
So write down the intervals.
Got it.
No, I don't.
Go.
Wait, are we using the black numbers?
Yeah.
Okay, yeah.
Frankie, go below. You're not gonna have enough room.
Like this?
No. Now,
There you go.
yeah, go over to the left. Scoot your whole self left. There you go. There you go. Now start right.
Okay. So this. Uh-huh. That's not in there. Yeah. I don't know.
Negative 3.414 to negative 5.0. Whatever that is.
What?
Frankie, what intervals is this thing possible of?
The
Between what two black numbers?
oh, between these two.
There you go.
Okay, I understand what's going on now.
Good.
Those and what's over there? Oh, that would be
3 to where?
infinity.
3 to infinity.
That's this side, and that's always that.
Good. Now
Um,
talk about your endpoints, brackets or parentheses. So let's start on the far left, negative 3.414.
yeah, because it's
Ah,
yeah. I'm gonna trust Kendra because she's pretty smart.
Yeah, it's same good with the one on the right.
Where does he send the other side?
Yeah.
No.
Not that one.
No, no, no.
There we go. Higher. And, upside down. Yeah, upside down.
Oh yeah.
Yes, and, bracket on 3.
Why is there a bracket on 3?
Because it's included.
Because included, oh, okay.
Oh,
Because
yeah.
3 makes the,
3 makes it the yeah numerator 0.
there you go. There you go.
Oh, I never wanted to be elected to teach anything.
Well done, sir. Now, let's just remember, why are these two numbers not included?
Because they're below
They made the denominator 0, which means they made the fraction undefined. Good. There you go. There you go.
We know what we're doing. We got this.
Done. Good. Now let's go to the very bottom. Let's run through this one problem. How is this problem different from the others we've done? Aha. This thing is not set equal to 0. Make it.
We just need to subtract it, right?
But you can't subtract or add if they're not the same.
Indeed.
That's not the answer I was looking for. Indeed, all state.
Indeed. Now, I need one fraction on the left.
So we need a common
Common denominator. Oh, yeah, we do. What's the common denominator? Common denominator. Hey, guys, we got, like, not long.
You still let me do
X plus 2 times x minus 1. Not both, well,
Both state.
I want to do it. Hope that makes you feel better. This fraction needs x minus 1,
The other way, X plus 2.
and this fraction needs x plus 2. Now, I could, if I had multiplied both sides by x minus 1 times x plus 2, that would have given me some trouble because then I wouldn't have had a denominator anymore. So that's why we're going to keep the right side, leave it alone, and we're going to just get our fractions on the left with a common denominator.
Alright.
So, so my denominator now is x plus 2 times x minus 1.
Before you simplify, 3x minus 3 times 2x plus 4.
Let's talk about the next piece. You got a minus, right? So why don't you just rethink that as plus and negative? And distribute a negative 2. So you had it right except for one piece. It'll be negative 2x minus 4. Yeah. When you have that minus, you make sure you distribute that minus to everything there. So it's minus 2x minus 4.
Okay.
So now what have we got?
You got x minus 7 over x plus 2 times x minus 7.
Now, since our last problem was done with much mirth, is that a good word? Mirth? Humor? Let's work through this one together, just real quick.
X.
What are our critical numbers?
7,
7, negative 2.
Yeah. Critical numbers are 7, negative 2, and 1.
Alright, folks, let's put them on.
Let's do it.
Oh, crud. I can't put numbers in there.
Mercy, mercy, mercy.
Full.
You ready?
Ready?
It's bigger than 7.
You're right.
Negative 3. Numerator? Denominator will be
Probably negative.
negative times
Negative.
If x is negative 3, the denominator will be negative times negative,
If we positive, we're just making it negative.
which is a negative divided by a positive. What does that negative sign mean graphically?
It's below x.
Below the x-axis. Good. What if x is 0? Numerator is negative. Denominator is positive times negative.
Oh, wait.
Positive. What does that positive mean graphically? Above the x-axis. Good. X equal 2. Numerator? Numerator? Negative. Denominator when x is 2.
Positive times positive.
If the next one's positive, 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 positive.
The next one's positive, 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 positive.
Yep.
Are you positive?
Actually, it's all positive. Yeah, it's not positive.
Positive, positive.
Now, what were we looking for here? Graphically, what are we looking for? On or below the x-axis. Now, let's take care of the below. Where is this function or this graph below the x-axis?
Negative infinity to negative 2.
Negative infinity to negative 2. And
1 to 7.
1 to 7. Where is the graph on the x-axis?
Wait.
7. Why 7?
Because it makes
Because when x is 7, the numerator is 0, but the denominator is not. And 0 divided by not 0 is 0. What about when x is negative 2 or 1? Undefined, so those numbers will not be included. 7 will be included. Nothing else.
I'll tell you what, when you're out there, you forget all of your information.
Say again?
Positive on the end, why don't you go to the end?
Because I was looking for less than. Okay, that was interesting.
Then I don't know how you teach up there, because as soon as I got up there, I just forgot everything that
Critical numbers and number line. Critical numbers and number line.